An electrical utility is a business that generates and distributes electrons, commonly called electrical power. Like any business, it gets paid for its product. And like retail stores, the utility measures exactly how much electricity each customer uses and charges the customer for that exact amount. Like any retail business, the utility uses a cash register, which it calls a power or utility meter. For the last 100 years, the power meter was a mechanical machine with a motor, gears, dials, and the like. The retail industry, of course, also used mechanical cash registers with motors, gears, and dials. However, the retail industry replaced virtually all of the old-fashioned mechanical cash registers with modern electronic ones by 1990. The utility industry still has close to 100 million old-fashioned mechanical meters throughout the United States in service. Utilities are now replacing their old mechanical meters with modern electronic meters called smart meters. The smart meter replaces the old motors, gears, and mechanical registers with electronic parts. So, what is in a meter and what makes it smart? Well, let's start with some basics, and let's start with the old-fashioned mechanical meter functions. Electricity is a form of energy. A scientist refers to the units of energy by a term called a joule, J-O-U-L-E. A joule is a measure of instantaneous power averaged over period time. However, a joule is a very small unit since 1 joule equals only 1 watt per second. How is this done? Well, homeowners think in terms of watts, and electrical utilities charge in units of 1,000 watts used over an hour's period of time and called a kilowatt hour. And a typical consumer power load of 500 watts used over an hour is a half a kilowatt. Used over 2 hours becomes 1 kilowatt hour, 1 kWh. A utility charges its customer typically once a month based on the number of kilowatt hours used over that month period, which is, of course, 720 hours. Thus, it can be seen that a basic power meter must sense instantaneous power, and it must accumulate that power second by second over the billing period. Now, let's see how this is done. Basic rule of science and electricity says that 1 watt is the product of volts times amperes. We started off, of course, K, W, H, which is 1,000 watts, and 1 watt is 1 volt times 1 ampere, we call that I, equals 1 watt. Volts times amperes equals watts. So in its simplest form, a basic power meter consists of a voltmeter. We think of an electrician's voltmeter. An ammeter. We think of an electrician's ammeter. A calculator, we think of a financial accountant's calculator or a homeowner's calculator. And a clock. And of course, we all know what a clock is. Just like the electrician's ammeter, the power meter measures current or amperes based on a magnetic sensor which is located inside the power meter measuring the electrons or the voltage and current flowing through the meter. That's a very simple concept. The calculator adds in time from the clock, and it produces the multiplicative product of volts times amps per period time, and it stores the resultant in what we call a memory location or a storage register. This is true in an old-fashioned mechanical meter. The storage registers become mechanical dials. This is true in a modern electronic meter using solid-state electronics. However, in 2004, the industry woke up and said it could benefit by sending the data to the utility wirelessly. Why? Because the old-fashioned electromechanical meters required a meter reader to go out and visit each and every meter once a month to record the positions of these dials and to take that information back to the utility company's computer, produce a bill, and put that bill in the mail. If I could transmit that information directly to the utility, then I automate that process. And that would be of a great business advantage to the utility companies. The reason, of course, relates to the fact that meter reader salaries, benefits, and overhead are all operating business expenses, which can be eliminated through this process. So, how do we do that? We add a transmitter, or more properly a transceiver, to the meter. We think of a transceiver, here's an analogy, a walkie-talkie, a radio and a transmitter in one unit. And this transceiver is now establishing what we call a wide area network, or WAN, communication path between the meter and the utility company. And typically, this occurs over what we call a utility-controlled or a utility-owned wide area network. Thus, the utility gets both its data necessary to generate bills from, as well as its ability to send commands and control signals to the meter. What type of control signal would the utility want to send to the meter? Well, as an example, things like turning on and off power. In the event that a bill is late, the utility can simply turn power off, and when the bill is paid, of course, remotely reactivate power. This does require that a relay be installed inside the meter. And of course, the preferred way to do that is to use an electronic meter, since it would not really make sense to retrofit old-fashioned electromechanical meters with things like relays and even transmitters. An example of a modern digital communicating meter is this Landis and Gear meter from the early 2000s. But is this meter smart? Well, hardly. Only the utility in this instance is smart, because the utility figured out how to automate its meter reading activities and save a lot of money in the process. And it also figured out how to get delinquent bills paid in a hurry by turning off service to those accounts. However, in 2005, things really started to change. At that time, I filed some major documents with the California Public Utility Commission suggesting that any new meters paid for by consumers from tax money or utility rate-based money must include many additional features. Chief among these new features is what we refer to as a universal meter interface, which would allow the meter to send its data inside the home for display and control purposes. At the same time, we convinced Southern California Edison, the nation's largest electrical utility company, that this must be done. And in fact, we even wrote the detailed specifications for a new meter design for Southern California Edison, which became the de facto minimum standard for any new meters in the United States. We knew at the time that Southern California Edison was the largest and most visible utility in the United States. And when Southern California Edison spoke, other utilities listened. Thus, the next generation of smart, or almost smart meters was born. How does this new generation of smart meters bring the data inside the home? Well, this is done with a second radio transmitter and receiver, or what we call a transceiver, again using our walkie-talkie analogy. And this transceiver is dedicated to what we call the local area network, or the home area network. In 2005, I proposed to Southern California Edison and its Open AMI Standards Group that the yet-to-be-discovered Zigbee be the transceiver's modus operandi. Now, 7 years later, Zigbee is growing up. Zigbee is rapidly replacing Bluetooth for power-sensitive applications, and Zigbee is becoming the in-home standard for home automation in the security industry. So, a modern electronic power meter can be made smarter when it communicates with smart customers through displays, controls, and smart appliances inside the home. As an example, a display. Another example, a smartphone, an iPhone. And of course, computers located throughout the home. However, in our country today, there is a fly in the ointment. The Zigbee transceivers are not yet turned on, and in fact, when the meters are installed, they're not even programmed. There are tens of millions of meters throughout the United States that have been installed, and their internal Zigbee transceivers are currently asleep on the job. No Zigbee, no data inside the home. What can be done to change this? Well, three things. Firstly, consumer awareness. Consumers must know about this, and they must demand that their utilities turn on their local home area network Zigbee transceiver. Without it, no in-home energy management system can work. Secondly, a utility must change its culture and learn to cooperate with customers. Utilities must embrace their customers having real-time information, which, by the way, the customers own. The information inside this meter is the customer's information. And this has been held up in court after court case in virtually all 50 states here in the United States. Now, of course, this can lead to a reduction in overall revenue for the utilities because when consumers have real-time feedback of their energy use, they invariably conserve power. Regulators must therefore provide an offset to increase profits to the utility based on the reduction of their gross sales. And thirdly, the utilities must become comfortable with the reliability of the Zigbee communications path and the plug-and-play nature of the consumer-owned equipment located inside the home or facility and operating on the Zigbee network. This, of course, must include a Zigbee to power line carrier bridge set when needed. And finally, one more thing needs to be pointed out. An energy management system could be made to work without a smart meter. However, that would require expensive equipment to be installed in the customer's fuse or breaker box. And it would also require a licensed electrician to come out to the homeowner's site and do the installation. Such an energy management system would be very hard for the average person to use because it does not have its tariff data automatically downloaded by the utility. Taxes, offsets, and adjustments are not considered in the calculations, obviously. And of course, complex tariffs, such as multiple tier, time of use, peak demand, etc., simply cannot be handled by such a device. And finally, such an energy management system will never 100% agree with the utility bill coming in the mail at the end of the month due to drift in the measurementation electronic technologies of both systems. Therefore, it's imperative that all old-fashioned electromechanical meters throughout the United States be replaced with digital communicating meters containing what we call distributed intelligence, as well as both wide area network communications and local area network communications operating over what we call the plug-and-play Zigbee network.